Welcome everyone to a quick overview of lesson 1.12 from calculus, which is continuity over an interval. We're going to be talking about essentially where functions don't exist, where we have problems with their domains. Most of the parent functions you probably were taught in pre-calculus exist over all real numbers, but there were some notable exceptions, and let's talk about those. The first and probably most major one that you discussed during your pre-calculus days was rational functions. And those cause problems when the denominator is equal to 0. You can see a nice asymptote forming here. And that happens at -3, which causes us to divide by 0 here. So whenever you have a rational function or a function with a rational component, you cannot divide by 0. The second major thing you were probably taught is that you cannot have a negative inside of an even root. So any inputs that would cause you to take the square root, for example, of a negative number do not exist in the real number system. And the same is true for any even root. Here I have the fourth root and the same modifications to show you that they do not exist when you take the even root of a negative number. Something that's important to note is that you can take the even root of 0, and that is 0. One of the other major ones that you were taught was probably logarithms, and logarithms have similar restrictions to even roots in that you cannot have a negative inside of a logarithm, but a logarithm has an extra component. Logarithms cannot have an input of 0. If I were to input -1 into that logarithm, I would get the log base 2 of 0, which is undefined. So logarithms, like even roots, cannot have negatives, but logarithms cannot have 0 either. There are some other places where we have some asymptotes form. You have your trig functions like tangent or secant, also cosecant as well. So do keep in mind those are not continuous over their domain as well. What if we combine them? If we look here, we have a combination of a rational function and an even root. Well, I can't divide by 0, and that's where this lovely asymptote is forming, but I also cannot input negative numbers into the root here, which is why this stops at 0. It is undefined anywhere in the negative numbers. So if you have a composition of multiple functions, keep in mind that the restrictions still apply. You cannot divide by 0, you cannot take the even root of a negative number, and you cannot have a non-positive number in the logarithm. So what if we have something weird like this? This is a very strange logarithm. We have negative numbers. I can input -5, for example, and I get out a value. Why is that? Well, if you notice in this rational system we have here, in this rational part we have here, well, 1, I can't get 0. If I input a 0, I will have a 0 inside the logarithm. That just doesn't work. It's undefined. But I also can't use -2 because -2 would cause me to divide by 0, which would also be undefined, which is why we have this nice asymptote at -2. We also have an asymptote at 0. Why does it not exist between -2 and 0? Well, if I were to input -1, for example, I would have -1 in the numerator, and I would have +1 in the denominator. I'd have a negative number, and I can't take the natural log of a negative number. So when you have these compositions, you really do have to be careful and check for all cases, because in this case, negative numbers, some of them can work because they'll reduce down to be a positive number inside. That is it for 1.12. These can be a little tricky, especially once you start to get to the combinations. So take your time, good luck, and I'll see you in the next video.